All right, well, is there anything in particular that you would like to go over? Like, do you have any specific questions from the notes or any homework problems, anything from the quizzes, the study guide, or you just have questions in general? What would you like to do? Or what would you like me to go over?
I was a little confused on question 18C from the study guide.
Okay. Okay. Can you all see the whiteboard?
Yeah, I can see it.
Okay. All right, let me find. So 18C.
Yeah, 18C.
Okay.
Oh, and E, please.
18, both in 18.
Yes.
Oh, the limits. Okay. Okay. Yeah, some of those limits can be a little tricky. Okay, so 18C. The limit as x approaches -4. X squared minus 16. Or x plus 4. So your goal for these limits is to be able to try to plug in this value that the x is pointing at. So we're trying to be able to plug in that -4. So like as of now, you can't, because that would make your fraction have a 0 in the denominator, so it's undefined. So we have to try to manipulate it. And one of the most common ways to do it is to try to factor everything and see, oops, see if that helps us. So for that x squared minus 16 on top, that'll factor into x plus 4 and x minus 4. And so now you can get rid of the x plus 4s. And you're just left with that x minus 4 in the numerator. And so now you can plug in the -4 for x. To give you a -8. So was this the right problem you wanted?
Yeah, I think I wasn't understanding the factoring portion, so I just put it as Danny.
Oh, okay. For most of these, if you're coming up with a DNE, that should be kind of like a red flag going, this probably isn't gonna be like that, because 95% of the time it's not D&E for a problem like for a problem like this. Your D&Es are pretty much gonna be reserved to like question number 19. Like where you had to evaluate the limit with the graph. So those D&Es are gonna happen when, you know, the left side doesn't equal the right side. But for like number 18, all of those should have had an actual answer. So if you're coming up with something like for number 18, if it's a D&E, I would really pause and look at it and be like, am I absolutely sure that it's a D&E? Because most likely it's not. Okay, and then E was the other one. So the limit is X versus infinity. I gotta make this bigger. There we go. Six X over the square root of 9x squared plus 5x minus 2. So what was your thought on this one?
think I just saw like the infinity and I was like, I don't know what to do.
Okay, so when x is approaching infinity or negative infinity, that's when you're comparing the degrees at the top and the bottom. And if the denominator has the bigger degree, then the answer is 0. If the top had actually, we didn't have that situation. If the degrees were tied, then it was just the ratio of their coefficients. So when you're looking at this, you only want to pay attention to the highest powers. So there's only one in the numerator, so that's kind of obvious. In the denominator, the highest power is your 9x squared. But since it's underneath that square root, it's gonna root and simplify into 3x. And so now you can compare your 3x to your 6x and you're like, oh, it's a tie. So then the answer would be 6 over 3 or just 2.
Okay, that makes way more sense. I think I just saw the infinity and I was like, I don't know what to do here.
Like, whoa. Okay, so like for D, it still has that infinity, but it's the same thing. Like the highest powers are, it's a tie because they're both squares. So for D, it would just be 7 over 14 or a half. Okay, let's talk about example F. It's like you didn't ask for it, but it's pretty similar. Because on this one, it's the same function, but it's now, x is now approaching negative infinity. And that normally doesn't matter, but sometimes it does. And in this one, it does. So you would do the same thing as we did in example E. You know, you're looking at that highest, the term with the highest power, you square root it. And then you can start to compare and it's like, oh, it's a tie again. So then it's the ratio of their coefficients. But you have to be a little careful sometimes when you're approaching that negative infinity, because x is approaching, or it's approaching negative infinity. So it's really a negative something. So if you plugged in a negative number into the top, that would be negative. If you plugged it into the denominator though, if you just plugged it straight into the 3x, that would obviously be negative. But you're plugging it in to the original. And when you square anything, how does it come out?
So it would come out positive and the overall would be negative.
Yeah.
Okay.
So yeah, your denominator is coming out positive, and the numerator is negative. So this time it's going to equal a -2.
Got it. Okay,
So
that makes sense.
Okay, so sometimes that does make a difference, but it's usually when there's something kind of weird in the function, like if you've got that square root happening, that'll typically change your answer if you're approaching negative infinity. Okay. So does anybody else have anything from the study guide that they wanted to go over? Do you have anything on limits? So anything from like chapter 14? So we just did some here where you had to manipulate the function anything. Like, do you want to go over anything with a graph? Like number 19 on the study guide.
I actually feel like that stuff's so much easier when it comes to like, I feel like it makes more sense. Like that stuff I can understand. But I
Okay.
feel like this stuff I don't get that much.
Okay. Yeah, I like evaluating limits with graphs too, because it's you don't really have to think a whole lot to do them. But it doesn't mean they can't be tricky.
If no one else has a question, 20B, I'm a little confused on. Like how to classify that one.
Okay. Can I clear the whiteboard?
Yeah, I'm good.
Okay. Okay, so 20 was asking about the continuity. If there's a discontinuity, how do you or classify it? Okay, so 20B. G of x is equal to x plus 6. Or x squared minus 2x minus 48. Okay, so this one I would factor as well. Because if it's factored, then you can tell what makes the denominator equal to 0 a lot easier than if it's not factored. So that would be x plus 6 and x minus 8. So once you factor it, then you can say what makes the denominator equal to 0. And that would be x is equal to -6, and then x is equal to 8. So once you identify the discontinuities, then you can go back to your function and then simplify it if you can. So this one, your x plus 6's cancel. So you're left with 1 over x minus 8. So in your new function here, this one, the one that you simplified, what makes your denominator equal to 0? And this can be for anybody, it doesn't have to be Alicia.
8.
Yeah, so 8 is still making that function, that denominator equal to 0. So since it's still in there, that's your non-removable discontinuity. The -6, it's no longer in the function, so that's the piece that you actually removed out. So that's your removable discontinuity.
Sorry, I was having trouble unmuting, but okay, that makes sense. Thank you.
Sure. So those are your discontinuities, your continuity. It would just be continuous everywhere else. So negative infinity to -6. And then -6 to 8. And then 8 to infinity. There you go. Okay, so we did a couple of limits. Algebraically, we got a factor or do something tricky like that. The continuity. Do you have any questions on like limits with a table?
I was a bit confused on the one from the quiz.
One from the quiz.
Like the table that we did on the quiz. I can't remember what it was. But I
I'll look
remember
that
I
up.
was just lost.
Okay. Oh, all right. Okay, so you had the one. Like this. Okay, so I gave you the function values, so -10, -100, -1000. And then kind of the same thing on the other side, just positive. One 0.01 and 8.001. Okay, so you had to fill in the first 3 x values and then also fill in the limit. As x approaches 8. Okay, so for your x values, you're following the same pattern on either side. So whether you're, over here filling in this side, or if you're over on the right, filling in those values. So the furthest box on the right and the furthest one on the left, they're always off by 0.1. So you're either adding or subtracting 0.1 to 8. So if you add it to 0.8, if you add it to 8, that would give you 8.1. But if you subtracted it from 8, that would give you what?
It would just be 8.
No, not quite. Let me write it this way.
Or 7.9, right?
7.9. Yeah. So that would be your first answer on the left. And then as you work your way in, you're adding and subtracting 0.01. So that would be 8.01. And then if you added, and then if you subtracted, that would be 7.99. So that's box, or yeah, box number 2. And then for the third one, it's you're adding and subtracting 0.001. So 7.999 would be the third. So for your answer, you entered in like negative numbers. You would only have negatives on the left side like that if your x is approaching 0.
Oh, okay, got it.
Otherwise, if you're approaching a positive number, then all your x's in that table shall be positive. If x is approaching a negative number, then all your x values will probably be negative. Okay, and then if so that takes care of the x's. For the limit though, you're seeing what these values are approaching, the function values. So as you approach 8 from the left side, so as you're coming in this way, you're hitting -10, then -100, then -1000. So if we did like 7.9999, that'd probably be -10,000. So your values are getting just more and more negative, and they're going off to where? They're gonna be negative what?
Would it be negative infinity?
Yeah.
Oh,
And then on the right side, you're hitting 10, then 100, then 1,000. So as you move in like just slightly closer to 8, it's like your y value adds in another 0. So that's going off to positive infinity. So then you look at, what you're approaching from either side. So the left was negative infinity, the right is positive infinity. Are those the same?
no.
No. So if they're different, that's your DNE.
Okay, that makes sense. Thank you.
You're welcome. Let's see, I think there might have been another version of that table. I think it was pretty much the same, but the outcome was different. I think for that one, it came out to an actual value, but the X's went or did something different. But let me look. Yeah, the other one, the X's were doing something similar. But the limit came out to, I believe, 18. I had an actual answer. Okay, do you have any other questions from the quiz while I'm here? Don't all ask at once. Okay, do you have any questions from the other quizzes? Like quiz 10 or 11?
Could we do 17 on the study guide?
Yeah. Is that the limit with the table?
Yes.
Yeah. Okay, so you don't have to fill in any X values. Everything's, oh no, you do. I'm sorry. Okay, so your function value is 12.9. 99. And 13. 1. Okay, and then the same thing, fill in the table and then evaluate the limit as X approaches 6. Okay, so you can always follow that same pattern if you're trying to fill in your X values. So the furthest box on the left and then the furthest box on the right. You're always going to get them by adding or adding and subtracting 0.1. So if you subtract 0.1 from 6, you end up with what?
5.9.
5.9. And then if you added it, you end up with
6.1.
6.1. Okay, and then as you work your way in, now you're going to add and subtract 0.01.
Mhm.
So 5.99.
Yeah.
1. And then the 0.001 add subtracted, so 5.999 and 6.001. Okay, so then you can look at your X value, or sorry, your function values. And as you work your way to the right, so the 12.9, 12.99, 12.999, those function values are getting closer and closer and closer to what number?
13.
13. And then as you work your way to the left, coming in from the right side, 13.1, 13.01, 13.001, those numbers are getting closer and closer to
13 as well.
13 as well. So since the two sides agree, like they're actually approaching the same value from either side, then the limit value is also 13.
Gotcha. Okay.
Was that your guess, or what, like what part of that was kind of throwing you?
Yeah, I think just having to fill in the X values kind of like stumped me for a second. So, because like I know the pattern of like doing the 0.1 and 0.01 and 0.001, but then like when there was none in there, I was just kind of like, but yeah, that definitely
Gotcha.
makes sense.
Okay.
Um, And then can we also do 14b as well?
Yeah,
I was
feel like
just
every-
gonna ask for that one. I'm so confused.
Okay, sweet. Yeah, whenever like the nth term like sequences turn into fractions, I like get kind of terrified.
that's a normal response. Okay, so 5, 1, then a fifth. And then 1/25. Dot, dot, and then a sub n is equal to, okay, so find the nth term of your geometric sequence. So what, you can identify two things. You can identify the A, and then you can also identify the R. So the A is whatever your first term is. So in this case, it's just 5. And then the R is whatever you're multiplying to give you the next term. So like, what are you multiplying every single time to give you the next number?
1/5.
1/5. So once you identify A and then R, your A sub n oops. Well, it's just going to be A and then times R to the n minus 1. And so now you can just fill in what you have. So your A is 5, R is a fifth. So whatever you end up with is your nth term. This one, though, can be simplified just a little bit. If you didn't do it like on a free response question, that would be totally fine. Where you have to watch out, though, is if it was multiple choice, because that might not be one of the choices. So like the 1/5, I can change that into to just 5. So when you take the reciprocal of a number, or like if you flip it over, what does that do to your exponent?
Flips them. So it'd be 1 minus n.
You're right,
Or-
yeah, it changes
okay.
the signs. So like, for example, like 1/2 is the same thing as 2 to the negative first. So it's doing the same type of thing because it's taking your exponent and it just makes it negative. So when you make a quantity negative, it just changes all your signs. It just flips them around. So you're right, that would just be 1 minus n.
Gotcha.
And
Okay.
now because they're both 5s, you can multiply them together and add up your exponents. So it would be 5 to the 2 minus n, because you're just adding up the ones. So if you just leave it, as 5 times a fifth to the n minus 1, that's totally fine. And if you simplified it to 5 to the 2 minus n, that would be fine too. Just be careful on those multiple choice questions, because it could simplify it to this one. And you might not realize, like, oh, how do I do that?
Right. Okay.
Okay, and just FYI, I got a notice from Zoom a few minutes ago that it was going to terminate the session in about 10 minutes, because apparently there's a time limit on my account. So if things just shut down, I'll restart it and I'll post another link so you can get back on again. But in about 4 minutes, it's going to just turn off, so don't panic. Like, what happened? Okay, so is that good for 14B? Does that make sense?
Yeah, that's great.
Okay. We have one like that in notes too. I think it was with twos or something as opposed to if. Maybe I'm just making it up. Oh well. Oh, we did, but maybe not. All right, let's see, what else do you want to do? Like anything from anything else from chapter 12 or anything from chapter 10? Chapter 10 was all the conic section, so like the sideways parabolas, as well as the up and down, ellipses, hyperbolas, and then it ended with the parametric equations. So those, if you're looking at the study guide, that would be like anything from like questions 1 through 9.
I just want to make sure I'm doing this right. To find the foci,